This is how we turn these images into these kind of videos with just a simple message on Telegram.
So this is the Lay's classic chips bag. Okay, so I just got this Batman boomerang, and I gotta say, it looks super sleek.
What you have just seen is only the beginning. This content generation system works automatically using Nano Banana and Veo3, two of the most important content generation models today. And the results are absolutely insane. All you need to do is send a photo and n8n takes care of the rest. In this video, you will learn how to create bots in Telegram, configure AI agents, and set up connections to work with external apps using Fall AI. All working perfectly thanks to n8n. If you're still wondering why you should learn how to use this platform, these are the search results from the last year. It's definitely a skill that is become more and more in demand. And if you like to reduce your learning time and spend more time earning, I invite you to check our community. There you'll find this and other workflows ready to use. Just copy, paste, and you're done. Alright, let's straight to the point. This workflow might look complicated, but trust me, it's very simple. Let's go through it together so I can explain step by step how it works. As you can see, everything began with this first node, which is a Telegram trigger. This will be our entry point. It is where we will receive the photos and the messages that we send from our phone. But before configuring this in n8n, we need to create our bot in Telegram. The very first things you have to do is open Telegram and search for Father. It is the official Telegram bot that helps you to create a bot. Once you find it, we are going to click on Start and you will see that a menu with commands appears. You write the next. It will ask you what you want your bot to be called. You can give it a name and we are going to give it the following name. After that, it will ask you for a username, which must be unique and end with bot. For example, you can have the following. And perfect. Once you do this, Botfather will give you an access token. This is super important, so save it in a safe place because we will need it to configure our Telegram node. Now let's go back to n8n. Since we already have our bot created, we are going to configure this node. As you can see, I have my bot configured. To set up yours, you need to click on this drop-down section and click on Create New Credential. A window will appear where you can enter your token. In access token, paste that token that Botfire gave you, give your credential a name to identify it, and that's it. Now we are going to send this photograph to Telegram along with the following instructions. This will activate our workflow. Once you have everything configured, you can click on Execute Workflow to trigger the node. As you can see in this test data, the bot receives the image perfectly along with the message. Notice that Telegram automatically generates different resolution for the same photo. For example, if you are testing this workflow and you want to save cost, you can choose a lower quality photo. The information in the output is exactly what we need to configure the following steps. Now that we have our bot created and working, we are going to use this new set to keep our workflow organized and secure. This set will handle the access token and the bot ID, which we will use later. Configuring it is very simple. In the assignment section, where we define our variables, add a name. In this case, I wrote bot ID, but you can choose any name you like. In the value section, this is where you paste the complete token that Botfather gave you. Once this is configured, you can click on Execute Node to test it. With this ready, we can have the base for our system configured. Now comes the interesting part. We need to get the actual path of the image that the user sent so we can download it. As you can see, I have a node called getFile, which is of type HTTPS. This node will make a request to Telegram API to obtain the file information. When we receive an image from Telegram, for example, we don't get that direct URL to download it. We only get the file ID. So this node converts that ID into a path that we can use. To configure it in the URL, we put the following link. Notice two important things. We are using this access token that we saved in the previous step. You should replace this dynamic tag with your bot ID. We are also using this dynamic tag to work with the medium resolution of the image. Once it is configured, we execute the node, and as you can see in the result, we obtain the file ID, the image size, and the file path, which is the path we will need later. With this information, we can now proceed to download the actual image in the next step. Now we are going to analyze the image with AI. We will use ChatGPT to automatically analyze the image and extract the key information that we will need to generate the UGC content. As you can see, I have a node called Analyze Image, which uses integration with OpenAI to examine the image. Configuring this node is very simple. We are going to set up our credentials, set the source to image, and in the operation, select Analyze Image. Then we select the model we want to work with. We tell it that the input we want to use is a URL. Notice how we are combining the both tokens that we saved in both ID and the file path that we obtained from the previous step. Finally, we will review the prompt. We give specific instructions so that it returns the information in a specific format, perfectly structured for use in the following steps. This will ensure consistent data no matter what type of image we send. Once these nodes process the image, we will have all the visual information structured, ready to generate content automatically. Now that we already have the image analyzed, it is important to give immediate feedback to the user so they know the system is working. For that, we configure this Telegram node that sends a quick information response back to the Telegram chat. Configuring this node is very easy. We add the chat ID, which ensures that the response arrives exactly in the same chat where the image was sent to us. Then we add a friendly message that confirms the process has started. In my case, I added the following. It uses the same credentials we configured for the first Telegram node. This small detail makes the user experience much more friendly, and once executed, the user will receive a status update of their request. Now we are going to create the perfect prompt. This is where we'll start generating the UGC content. This agent takes all the information we have generated and turns it into an optimized prompt to generate authentic and casual UGC content. Let's review the configuration of this node. In it, we specify two important things. The first is the user prompt. Let's take a look at it. In this prompt, we basically combine three key elements: the user instruction through this dynamic tag, the image analysis performed by the OpenAI node, and the format preferences, where vertical aspect ratio is set by default for this type of content. The next step is to configuring the system prompt. This is basically the brain of the system. Here we teach the agent to create content that looks like real influencer photos. Not professional renders, it must have a casual style, authentic realism, and it must preserve text so that logos and writing elements remain exactly as they appear in the original image. It should also use diversity in its characters, especially important if the user only provides the product image. Additionally, we ask it for a structured output so that the agent always returns a clean JSON with only two fields, the image prompt and the aspect ratio of the image. But before moving on to the next node, let's review three tools. And all of these nodes and tools can be found by searching of them in the sidebar of your project. The first tool this node uses is a team node, which works like the internal brain of the agent. It allows it to reflect and validate before giving a final response. The next one is an OpenAI node, which we most configured with our credentials, since this is the processing engine that executes all the logic. And the third tool is a structured output parser with the following code. This tool is super important because it guarantees the perfect output format, from the emotion, the action of the character, to how the product is presented in the scene, and we activate the autofix option. It allows it to automatically self-correct, generating the final result, a perfectly structured JSON, that the next node can process it without errors. With this ready, we are going to start using one of the trending tools of the moment, Nano Banana. This will allow everything to come to life. This node uses Nano Banana, takes the perfectly structured prompt we created and turns it into an image. Before reviewing the configuration of this node, let's talk about the website File AI, which is a specialized platform that gives you direct access to the best image generation models on the market. There you can review the documentation for each model we use during this tutorial. Let's go back to n8n to review the configuration of this node. For the URL, we use the following, which is the direct endpoint for using this tool in File AI. We select post method, add authentication through a header to access the File AI API, and configure the following body: Here are some important technical details. Some characters can escape from the prompt, so we use the following approach to correctly handle quotes and line breaks that may come from the previous agent. We also configure the number of images so that it generates only one perfect image. As you can see, we get a response with a direct URL of the generated image. In just a few seconds, we have transformed a product photo into authentic UGC content, ready to use in marketing campaigns. Now that we already have our image, it is time to create authentic UGC videos. For this, we will rely on the next AI agent. This one is our specialty in generating prompts for videos that look like real TikToks or Instagram content. The user prompt combines the same information as the previous agent, but with a specific focus on video. For example, it ensures the logos and text appears exactly as in the original image. The dialogue must always remain natural to create casual conversations. We use ellipses for natural pauses. It also automatically calculates how many 8 seconds videos are needed based on the total duration requested by the user. Now let's go deeper into the system prompt. This agent is specifically trained to create videos with an authentic visual style. It uses descriptors, for example, to achieve a perfect look, generate conversational dialogues, and we also ask it to include people of different ages to ensure the output is varied, even if the user only provides a product. It calculates the necessary scenes to determine the exact number of videos based on the request duration. And just like the previous agent, it uses the same three tools. It is connected to the Think tool node, uses OpenAI as its processor, and has its own output parser to guarantee the correct JSON format. We execute this node, and as you can see in the results, it generates an array of scenes where each video includes the natural dialogue, the specific actions, and the technical configuration, such as the aspect ratio. With this node, we transform any product into a set of instructions to create authentic UGC videos ready to generate with Veo3. Now, with this split out node, we are going to take the array of scenes that the previous agent generated and separate them into individual elements so that each video can be processed independently. The configuration of this node is very easy. In the section Files to split out, we are going to add the following. This tells it exactly which field to split from the previous JSON. Now, if we execute it, we will see that we have the following separated elements instead of a single array. Each element now contains all the necessary information to generate an individual video. Now we arrive at the most important moment. We are going to convert our prompts and the generated image into the real 3D videos using Veo3. If you don't know, Veo3 is currently the most realistic video model available. So it is the perfect tool to achieve what we are aiming for. To configure this node, we will use the following URL, which is the final endpoint for image to video conversion. We are going to select the post method and add our authentication with File AI. You can check the models and direct documentation on the official site. I'll leave the link in the description. The next parameter uses the image we generated with n8n as the starting point. We add a specific duration perfect for social media content. It is important to configure this section with its batching size. Depending on the duration of the video that the user requests, we will need more or fewer videos. Configuring this section ensures that each video is processed individually. The batch interval option makes sure it waits at least 3 seconds between requests to avoid API limits. We execute it, and as you can see in the results, each video enters in the queue with its own request ID. In addition, the system gives us a URL to monitor progress, obtain the result, and cancel it if necessary. The next step in our workflow is this wait node, which pauses the workflow for 100 seconds so that Veo3 can finish generating the videos. Veo3 needs between 60 and 120 seconds to render 8 seconds video, for example, in 720. Without this stop, the next node will try to fetch videos that are not yet ready. Now we are going to use this HTTP request node to obtain the final videos. We configure this node to use the following dynamic URL to get the correct URL for each video using its ID. We use our previously configured File AI credentials, and this node generates the video, fully generating the UGC videos. As you can see, we get a direct download URL with which we can view the final result. Up to this point in the tutorial, we have transformed a simple product photo into fully authentic UGC videos with natural dialogues. Before continuing with the process, we are going to use this if node as a quality control. Let's review the configuration of this node. The following dynamic tag verifies the video URL. If the video is true, the video is ready and continues to the next step of the process. If it false, it returns to the wait node to give more processing time. However, if we send these videos as they are, we will send each one separately. Therefore, we are going to use this aggregate node, which combines all the video URLs into a single organized list to send to the user in a clean way. This node is configured as follows. In the file to aggregate, we add the following expression that extracts only the video URLs. In the output file name, we add the following expression that renames them for easy access. We enable the rename file option, we execute it, and instead of sending 3 separate messages to the user, we can create a single well-formatted message with all the generated UGC videos. This allows us to merge them in the next step. To do this, we are going to use FFmpeg, one of the industry standard tool for video processing. We are going to use through the Veo API to automatically handle the concatenation of these videos. To do this, we configure this HTTP request node that combines all the individual UGC videos into one continuous video. If 2 or more separate files were generated, we create a single fluid piece of content that tells a complete story. To configure it, we use the following URL, add our credentials, and include the following JSON in the body, which sends the URL generated in the previous step. When we execute this node, the first thing we get is a unique request ID to monitor the merging process. The next thing is a tag that indicates the process in the queue. We need to add another wait node, which gives FFmpeg to complete the merging of all the videos into one. We configure it as follows. We add 100 seconds so that the FFmpeg API can process and merge all the videos while maintaining quality and synchronization. Once the specified time is over, the next step is to use an HTTP node to retrieve the final video created by FFmpeg. The node configuration is as follows. We use the following dynamic tag followed by the unique merge task ID to obtain the final result. We add our credentials and we executed. This node generates an optimized file ready to be shared directly across all your social networks. Before sending the final result to our user in Telegram, we are going to check if the video was completed correctly. For now, our request is still pending, so we are going to use a new wait node to give FFmpeg enough time to complete the merging. You can configure it with 100 or measure how much time is really needed for concatenation. The last step of this process is to retrieve the complete video. For this, we use this HTTP node configured with a get method to fetch the final video. We use the following URL, which contains the following dynamic tag that uses the unique merge task ID to obtain the final result. The authentication is the same as we have been using for Veo AI. By executing this node, you get the complete video with all the results merged. Now we will use this if node, which performs the same verification as before, but this time with the complete video. We use this dynamic tag to verify that the merged video URL is complete. If the video is ready, it will continue to the final step to send it to the user. Otherwise, it will return to the wait node to allow more time for the merging process. Finally, we are going to use this new Telegram node to complete the process by sending the final UGC video to the user. We configure our credentials, select the send video operation, configure the chat ID by writing it directly or by adding this dynamic tag. In the file field, we add the following dynamic tag, which is the URL of the final merged video. The user receives a continuous, high-quality video that combines all the UGC scenes, authentic content that looks like it was recorded by real influencers, with different characters and casual scenarios perfectly joined together. Now, let's talk about the real cost of generating a complete UGC ad with artificial intelligence. First, the ChatGPT model we are using to analyze the image costs approximately 0.01 per analysis. The image generation with Nano Banana costs about 0.039 per image. Each 8-second video using Veo3 Fast costs around 1.20 with audio included. In addition to merge, for example, 3 videos, we use FFmpeg Hub with an approximate cost of 0.10 per merge. So from a simple product photo to a professional UGC video in minutes. Image analysis with ChatGPT, specialized prompt generation, image creation with Nano Banana, video generation with Veo3, and final merging with FFmpeg, all connected through a simple Telegram message. If you like to reduce your learning time and spend more time generating income, join our Mint at Will community. There, you'll find this complete workflow and many other ready-to-use copy and paste systems. Don't waste hours configuring alone. Access solutions that work from day one. In addition, you'll have direct access to a community of people who are building real automated income streams with real-time problem solving. The link is in the description. Without further ado, thank you for watching. Don't forget to like and subscribe. See you in the next video. Until the next time.